Welcome back to this channel. So in this video we are going to be covering polynomials, and we are going to be specifically handling remainder theorem. So this video has been presented to you by Uace, and you are advised to subscribe to the channel or share the video to your friends so that you can benefit as a family. So with remainder theorem, what do we mean? So we are going to start by explaining what remainder theorem represents. And we are saying that when a polynomial of x, that's how we read it, when polynomial of x is divided by a given factor, and in this term, our factor is x minus a, our quotient is going to be denoted by quotient of x, which is 2 into bracket of x, and our remainder is going to be denoted by r of x, or here I just represented it by r. Then we are saying that our polynomial will be given by any polynomial function of x will be given by the divisor or by the factor. We call this one the divisor multiplied by the quotient. Now we are going to be looking at what the quotient really means, and then we add on our remainder. So notice that the divisor and the quotient multiply each other, but for the case of the remainder, we introduce in an addition sign. And we are saying that for polynomial, now if you substitute, when you are getting the remainder, you get your divisor or the factor, and then you equate it to 0. So you notice that if you equate this bracket to 0, your x will be equal to a, and then you substitute for a in the polynomial function of x. So that's why we are having this expression. So you're saying that provided we have polynomial of a function of a, that means that we got a and we substituted it in our function. So a, if you put here a, it will be a minus a, and it will be 0. So 0 times 2x will be 0. And you're saying that if we get polynomial function of a, our remainder will be equal to 0. Whenever you substitute for the value of x, whatever you get in the expression is called the remainder. And we are saying that we got a from our factor. The factor is always given in a bracket format. And we are saying that x minus a is a factor of polynomial x. So we are saying that this approach can be extended to the division of polynomial function of x and polynomial function of dx of the degree less or equal to the degree of f of x. So we are saying that if the division gives the quotient, now notice that the quotient, our quotient is going to be the value above the root. If the quotient 2 of x and the remainder, which is denoted by r of x, then our function or our polynomial of x will be given by the divisor. I've told you dx is always the divisor, and then multiplied by the quotient of x, and then for the remainder we just add it to the product. So it's the divisor multiplied by the quotient and then plus the remainder. And we are saying that where r of x is going to be of lower degree than g of x. Now we are going to look into this more in details in the examples that we are going to be handling. So we are saying that the remainder theorem, let's look at it into details and into examples. So you're saying that if polynomial of x, if provided you are given polynomial of x and it is being divided by a factor x minus a, I've told you these are called factors. Now when you equate those factors to 0 and you make x the subject, that's called the root. But if you're given a bracket like this is a factor, and after equating it to 0 and you substitute it in any polynomial, the expression becomes a remainder. So you're saying that proof, you're being given an example here. You are being told that polynomial of x is divided by a factor x minus a, and the remainder is pa. So prove that polynomial of x is given by, this is a divisor, multiplied by the quotient of x, then plus the remainder. Whenever we are approaching such kind of questions, you start by equating the factor to 0. Now I did this only in this example. With the continuing videos, I'm going to be skipping this step. So when you equate the factor to 0, you make x the subject. You make x the subject by taking a on the other side. So here a has been negative. When you bring it this side, it turns to positive. So our x is going to be equal to a. Now we get our polynomial function of x, and we substitute. Where there is x, we substitute with a. And then we see what we remain with. Now where was x, we put a. So a minus a gives you 0, and 0 times quotient of x will be 0. So you remain with 0 plus r, which will eventually give you polynomial of a will be equal to the remainder r. Now what does that mean? It means that whenever you equate your factor to 0 and you make x the subject and you substitute for the value of x, always what you get in your expression is called the remainder, and that's what the remainder theorem is about. In this slide, we have provided some examples, and in these examples, we have prompted you to find the remainders when the respective polynomials of x are being divided by the given factors. So Roman number 1, we have told you that polynomial of 3x squared minus 4x squared. Now notice that this one was supposed to be cubed. Polynomial of 3x cubed minus 4x squared plus 5x minus 8 is being divided by x minus 2. And in Roman number 2, 2x cubed minus 3x squared minus 5x plus 6 is being divided by x plus 2. And the same thing applies to Roman number 3 and Roman number 4. So let's save time and try to look at how each of them can be best approached. I've told you the remainders are got by getting the divisor or the factor and equate it to 0. After doing that, you make x the subject. And then on substitution into the polynomial of x, whatever expression gives you is called the remainder. So let's look at that very quick. So looking at the solutions, we are saying that polynomial of x is given by, this is the general formula. So always polynomial of x is given by the quotient of that very function x multiplied by the divisor. And then we add on our remainder. So we are saying that qx is called the quotient and dx is always going to be called the divisor. And also r is going to be called the remainder. So we are saying, if we start with Roman number 1 as our example, we are saying that the divisor, our divisor in this case is x minus 2. So as we have said, you get your divisor and equate it to 0, and then you make x the subject. And after doing that, you substitute for x in your polynomial. So our polynomial is this. So we come back and we substitute for elite. Now notice that all the expressions were given the question were not given in terms of polynomial of x. So the first step here is to let your polynomial to be equal to polynomial of x to be equal to this. So let me hope that is clear. So you include here word let polynomial of x be equal to the function you are given. So we are having polynomial of 2. And I've told you substitution, whatever you get is called the remainder. Once you substitute for 2 where there was x, now here there was x cubed, that's why you're having 2 cubed. Here there was x squared, that's why you're having 2x squared. Now whenever you're substituting, you're advised to use brackets because brackets in pure math is what symbolizes substitution, and you're always given a mark for substitution. So we always endeavor to use brackets. So whenever we substitute for x and we simplify, we shall get 24 minus 16 and then plus 10 minus 8. And when you try to simplify, you are going to get your overall answer as 10. But I've told you after substituting for a given value of x, whatever you will be getting is called the remainder. And in this case, our remainder is going to be 10. And we are saying that therefore, the remainder when polynomial of x cubed minus 4x squared plus 5x minus 8 is divided by our divisor, in this case it was x minus 2, is going to be 10. Moving on to the next example, or Roman number 2, we always start by quoting the general formula. So the general formula for finding any polynomial of x, is always given by the quotient multiplied by the divisor, and then you add on the remainder. So polynomial function of x is given by 2x cubed. If you look at Roman number 2, this is what they gave us. Now I've always forgot this word of letting because we are not given that. So you always let, just like you do in paper 2. You always let your function that has been given to be polynomial of x. Now your divisor was already given, that's why I'm saying that divisor of x is going to be x plus 2. Now what did we say you do with the divisor? You always get the divisor and you equate it to 0, and then you make x the subject. So this is positive 2. When you take it this side, it becomes negative 2. So you're having x is equal to negative 2. And then what you need to do after making x the subject is substitution into your polynomial function of x. Now when you substitute for x equals to negative 2, whatever you got is called a remainder. So when we substitute for negative 2 here in this expression, I've told you always substitution use brackets, and we always award the bonus mark for that. So when substituting for x, wherever there is x in the polynomial function of x, you put negative 2. And picking your calculator to simplify, you are going to get polynomial of negative 2 being negative 12. And I've told you, after substitution, whatever you get is called the remainder. So that's why we are saying the remainder when our polynomial function of x is divided by x plus 2 is going to be negative 12. So going to Roman number 3, we are going to be repeating the same thing. Roman number 3, any polynomial function of x is given by the quotient function of x multiplied by the divisor, and then you add on the remainder. And then you are going to say equating. We always equate the divisor to 0. Now equating the divisor to 0, and then you make x the subject. What do you get? You are going to get x is equal to 3, because our divisor was x minus 3. So making x the subject is going to give you 3. So you get back your expression of polynomial of x, and you always first let if they have not given it to you having polynomial of x. So you let polynomial of x to be equal to the expression that they have given you. And then you get the value of x you have made the subject, and you substitute into the polynomial of x. Now when you do that, you use your substitutions. We always recommend to use brackets because we always give a bonus mark for this. And then after that, you can use your calculator and you come up with a final answer. So the final answer is going to be 39. And I've told you, whenever you make a substitution, whatever the remainder you get is whatever the answer you get is called the remainder. So in this case, our remainder has been 39. So the remainder, when polynomial that was given, polynomial of x, is divided by our divisor, is going to be 39. Now the same concept goes with Roman number 4, and that's why I'm going to be very quick here. So your divisor was x plus 1, and then you get your divisor, you equate it to 0. And after equating it to 0, you make x the subject. After making x the subject, you come back into what you have related to be a polynomial of x, and then you substitute for the value of x. Substitution always carries a mark, so you use brackets, and then you get negative 1 minus 10, and the all total, you're going to get negative 11. Like we have said, after substitution, any expression you get is called the remainder. So that's why we are saying that the remainder, when our polynomial of x is divided by x plus 1, in this case is going to be negative 11. Now we are saying, we are giving a note. Suppose our polynomial f of x has repeated roots or repeated factor. Now you have to pay attention here. A repeated factor, in this case we give an example of x minus a. Now for repeated factors, I want you to note this. Always when a repeated factor is denoted by having, you see the divisor which has a squared towards on the top as a superscript. So whenever you're having a repeated factor, always know that that factor is going to satisfy both the polynomial and its function, or and its derivative, and we always get the derivative by carrying out the differentiation that you have already done earlier in your pure mathematics. So we are saying that, so by differentiating, so remember that our polynomial is going to be this, so we need to get its derivative. By differentiating, now remember that this is product rule. What you are going to do, you are going to leave the bracket which is squared constant, and then you differentiate polynomial of gx. So after leaving this one constant and differentiating polynomial of gx, we get g prime of x. So the prime denotation will indicate that you have differentiated polynomial function of g of x, and then plus, as product rule says, you leave polynomial of gx constant, and then you differentiate your bracket. Now when you differentiate your bracket, you take 2 down times the bracket, which is x minus a, and then times the derivative of the bracket. The derivative of the bracket is going to be 1. So you end up getting such an expression. So this is going to be our derivative of our polynomial. And I've told you, for a repeated factor, the factor satisfies both the polynomial and its derivative. So always remember that. So we are saying that, hence, if the polynomial function of x has a repeated factor, and I've told you can realize a repeated factor by seeing a squared superscript on the divisor. And then we are concluding that, hence, if polynomial function of f of x has a repeated factor, and that repeated factor is x minus a, then x minus a is also a factor for its derivative, which is the note I'm from telling you. For any repeated factor, or if you see any repeated factor on the polynomial, just know that the condition present the factor satisfies both the polynomial and its derivative. So you have to be very keen when you're approaching such questions, because such questions are highly examinable whenever we are setting simultaneous equations. And you are saying, therefore, if x minus a squared is our repeated factor of a polynomial function of f of x, only if if you substitute, remember that you are going to equate this factor to 0 or your divisor to 0, and then you make x the subject. So x the subject will be x is equal to a. So you have to substitute f into a and also into its derivative. Now remember that both of these ones must be equal. That's what it means, that both the factor satisfies both the function and its derivative, like we are going to be covering in examples. Now we are saying that example 2. So what is example 2 talking about? Now example 2, we are going to look at examples under this. So example 2 has said, given that the polynomial function of f of x is equal to x cubed, plus 3x squared minus 9x plus k as a repeated linear factor. Find the possible values of k. Now here we are saying that solution. So in the solution, what are you going to provide? We are saying that polynomial function of f of x is equal to this. But now they talked about repeated linear factor. Whenever they are talking about repeated, just know that you're supposed to get the derivative of the function. So that's why you're having the polynomial. Now on getting its derivative, differentiating x cubed will give us 3x squared. Differentiating 3x squared is going to give us 6x. And differentiating negative 9x is going to give us negative 9. Differentiating a constant k is going to give us 0. So that's why you're not seeing anything attached to it. So trying to simplify this further, we shall prime factorize out 3. When prime factorize out 3, you remain with 3 into x squared plus 2x minus 3. And then you also solve this equation. You prime factorize this equation. You can use your calculator. When you use your calculator, it's going to give you x1 to be equal to 1, and the other x is going to be equal to negative 3. So to get factors, you just multiply each of them by negative. So that's why we are having 3 multiplied by x minus 1 multiplied by x plus 3. And we are saying that the conditions for repeated factor, they have told us that this polynomial has a repeated factor, but here we are having two factors. So which one is which? We have to substitute each of them. We have to use try and error so that we can see which factor satisfies both equations. So if you start with x minus 1, if you equate it to 0, your value of x will be 1. So if you substitute f into 1, what do you get? If you substitute f into 1, you get k being equal to 5. And with this factor, if you equate it to 0 and you make x the subject, you are going to get x equals to negative 3. And if you substitute it into this, you are going to get k equals to negative 27. Now we are saying that the possible values of k are going to be equal to 5 or negative 27. Here we are going to be going through how you can obtain a remainder using the long division method, which some of you have been exposed to in most of your schools. Now we are saying that to obtain the remainder by long division, you are going to undergo the following mechanisms. I've provided them in words so that you can first read before approaching the questions. And so if you are to look at the steps, if you look at step 1 is telling you that you must make sure the polynomial is written in descending order, and that means that you start with the highest power of x. So you start with the highest power of x whenever you are arranging your polynomial. And we are saying that divide the term with, as in step 2, divide the term with the highest power inside the division symbol by the term with the highest power outside the division symbol. Now, by saying by the term with the highest power outside the division symbol, we are talking about the divisor, the highest power of x on the divisor. We divide it by the highest value of x on the polynomial. So this is what this statement means. And then step 3, we have told you to multiply or distribute the answer obtained in the previous step in front of the division symbol. Now the reading this is sounding more complex, but you're going to do it practically. This statement is trying to mean that you get the quotients that you have got, and then you multiply it with the divisor. After that, you subtract it from the polynomial, which is on step 6. Subtract and bring down the next term. Now step 4, we are saying that you're going to repeat Roman number 2, Roman number 3, and Roman number 4 until there are no more terms to bring down. Now step 6, we are saying that you're going to write your final answer, and the term remaining after the last subtract step is going to be the remainder, or is what you're going to remain with after seeing no further division is always going to be called the remainder, and it must be written as a fraction in the final answer. That remainder you have got, you divide it with a divisor. That's what we mean by representing it as a fraction. Here we are going to be looking at some live examples. Now in these examples, we are going to be using long division to obtain the remainders. Now in the first case, we are using remainder theorem. Substituting the divisor, you equate it to 0, and then you make x the subject, and then you substitute into the polynomial. Whatever you get is the remainder. So we are going to do that using the long division method. Now the long division method is the most safest way of getting answers. So you have to follow step by step so that you can master how it is done. So Roman number 1, where our divisor is going to be x squared plus x minus 6. Like for long division, we always put our divisor there. So we put our polynomial under the root. So the polynomial which you are given is there, which is under the root, and it is this one. So how are we going to start dividing? Now this is where you have to pay extreme attention. When you're dividing the polynomial with a divisor, you get the highest powers of x on each of them. Now here on the polynomial, we're having x cubed. Now on the divisor, we're having x squared. Now what we do, you get the x cubed on the polynomial, you divide it with the highest power on the divisor, which is x squared. Now what do you get? If you divide x cubed, which is present on the polynomial, and then you divide it by x squared, which is the highest power of x present on the divisor, you're going to get x. Now after getting that x, you multiply it. Assume that this 2 is not there. The plus 2, I'm going to show you how it came about. After getting the x, you multiply it. You multiply x with x squared. Let me first clear this up. After getting your quotient, which is x, you multiply it with the divisor. So if you multiply x with x squared, you are going to get x cubed. Whatever the result, you record it down on the next line. When you multiply x with x squared, you get x cubed. When you multiply x with x, which is present in the divisor, you're going to get x squared. And when you multiply x with negative 6, you're going to get negative 6x. So let me hope that has been clear. And that's what we shall be keeping on repeating. Now after doing that, we subtract because we want to eliminate the highest power of x on the polynomial. Now subtracting, now I forgot to indicate the sign of subtracting here. Now on subtraction, x cubed and x cubed will go, and then we remain with 3x squared minus x squared, then it will give you 2x squared. Then negative x squared minus negative 6x, and then you remain with positive 2x. And then negative 12 minus 0, you are going to remain with negative 12. Now you repeat the same thing, you get the divisor, you get the highest power on the polynomial. Now the polynomial you are left with is here. Let me first change the ink. The polynomial you are left with is this. So we do the same thing that we did in the first step. You get the value with the highest power of x. Now in this case, in our polynomial is 2x squared. Now 2x squared, we divide it by the highest power on our divisor, which is x squared. Now once you divide 2x squared by x squared, you are going to get positive 2. And then the value you get, you multiply it again by the divisor. So 2 multiplied by x squared on the divisor, you are going to get 2x squared. And then 2 multiplied by x on the divisor, you are going to get 2x. And then positive 2 multiplied by the negative 6 on the divisor, you are going to get negative 12. After getting that, you subtract, because we aim at eliminating highest powers of x. Now in subtraction, you are going to get 0. Everything is going to narrow down to 0. So how can we present our polynomial then? Now remember that we gave a general formula for representing a polynomial. And we say that a polynomial is always given by polynomial of x is equal to the quotient multiplied by the divisor plus the remainder. Now this could be in the same form, but we divide it by the divisor, that's why the quotient is alone. But if you multiply throughout by the divisor, then you remain with polynomial of x being equal to this divisor is going to multiply the quotient and then plus the remainder, and in this case our remainder was 0. So we are saying that quotient of x is always that value above the root, which in this case is x plus 2. So that's our quotient, and our remainder is 0, which is the answer you get when you can no longer do any more further long division. Now I'm going to look at 3 more examples so that this one becomes more clear. We look at Roman number 2. Our divisor was x minus 3 and our polynomial was 2x power 4 minus 8x cubed plus 5x squared plus 4. Now how can you solve this? Now you put the polynomial. Initially you start by putting your polynomial under the root and then the divisor outside the root, and you repeat the same procedure that you have been doing. And we say that for you to start dividing, you get the highest power, the value with the highest power on the polynomial. In this case is 2x power 4. And then you divide it by the value of x on the divisor, which has the highest power. So in this case we only have one value of x, which is x. So you get 2x power 4 on the polynomial, you divide it by this value of x on the divisor. So you end up getting 2x cubed. Now getting 2x cubed, you write it up above your polynomial. Now assuming that all of them are not around, you are going to see how they are going to come about. So that means that you're having 2x power 4, you divide it by the x which is present on the divisor, and then you are going to get 2x cubed. Then after getting 2x cubed, you multiply it out by the divisor. So 2x cubed multiplied by x on the divisor, you are going to get 2x power 4, and you put it down the polynomial that you are having. And the better way to practice this is to take notes or write this down as I'm directing you. So 2x cubed, you multiply it with x on the divisor, you're going to get 2x power 4. And then 2x cubed times negative 3, you're going to get negative 6x cubed. And then you always subtract to eliminate the highest power on the polynomial. So 2x power 4 minus 2x power 4 gives you 0. But negative 8x minus negative 6 cubed, 6x cubed is going to give you negative 2x cubed. And then the others are going to be minus 0. That's why you bring them automatically down. And then you repeat the same procedure. Now the polynomial you're having a highest power of x cubed, having a coefficient of negative 2. Now you get that coefficient, and then you divide it by the highest power of x on the divisor. Still our divisor is going to be x. So when you get negative 2x cubed, which you stopped on, I mean this one. If you get negative 2x cubed and then you divide it by x, you are going to get negative 2x squared. And then you come and you put it here. So first of all, we had 2x cubed. And then you've added negative 2x squared. Now let's see how others come about. You still do the same thing. You get negative 2x squared and then you multiply it with your divisor. So negative 2x squared times x, you are going to have positive 6x squared. And then negative 2x, you're going to get negative 2x squared times x, you're going to have negative 2x cubed. And then negative 2x squared times negative 3, you're going to get positive 6x squared. Now when you subtract to eliminate the highest powers of x, you are going to get negative 2x cubed minus negative 2x cubed to give you 0. And then 5x squared, you less 6x squared is going to give you negative x squared. And then the others are going to be minus 0. That's why you just bring them automatically down. And then you repeat the same thing. The polynomial you have now is negative x squared plus 0x plus 4. So if you divide negative x squared divided by the x on our divisor, we are going to get negative x. And then we get that negative x and then we multiply it through our divisor. So it's going to be negative x times x to give you negative x squared, and negative x times negative 3, you're going to get positive 3x as you are seeing it there. And then you subtract. Subtracting will take away the highest degree of x, and then you remain with 0x less negative 3x. Now remember that I didn't indicate the less sign, and you should indicate it in your work. So 0, you less 3x, you're going to get negative 3x, and then plus 4. Plus 4, you less 0, you're going to get negative 3x plus 4 as your current polynomial. Then you repeat the same thing. You get negative 3x divided by x on the divisor. You're going to get negative 3. You put it above the root. So that means that you have understood how this quotient was got. So negative 3 times x, you get negative 3x as present here. And then negative 3 times negative 3, you're going to get positive 9. And then you subtract to see whether you remain with the remainder or not. So subtracting will give you negative 5 as the remainder. And negative 5 can be divided by x, that's why we stop there. So you're saying that our polynomial 2x power 4 minus 8x cubed plus 5x squared plus 4 will be given by our quotient of x plus the remainder divided by the divisor. And you're saying that the quotient of x is always the value above the root, which in this case was 2x cubed minus 2x squared minus x minus 3, and your remainder was equal to negative 5. And you're telling you that quotient of x symbolizes quotient, and remainder is equal to r. Now explaining one more example, other examples are going to be used. So this, we are being given this polynomial, and we are given a divisor of x plus 1. So repeat the same procedure. How did we get this quotient is what you are looking for. So you put the polynomial under the root, and you put the divisor besides the root. Now you get the value with the highest power of x. In this case it's 5x power 3. And then you divide it with the value of x which is in your divisor with the highest power. In this case was x. Dividing 5x cubed by x, you get 5x squared. Now you put it immediately above your root. So initially you have 5x squared. Once you get that, you multiply this one by the divisor. So if you get 5x and then you multiply it with x, you will have 5x squared. Now the answer, you have 5x power cubed. Now the answer, you note it down. That's why after multiplying, you see here, we shall get 5x power 3. And then 5x squared times positive 1, you're going to get positive 5x as you are seeing here. After doing that, you subtract so that you can eliminate values of higher powers of x. So 5x cubed minus 5x cubed will give you 0. But negative 6x squared minus positive 5x squared is going to give you negative 11x squared. And then the others are with less of 0. That's why they come automatically down. Now you do the same thing. Now the polynomial you are having is this current one. So we do the same thing. We get negative 11x squared. We divide it by x on the divisor. So we shall get negative 11x. And then we get that quotient you have got here that you have added, and you multiply it through by the divisor. So negative 11x, you multiply it with x to give you negative 11x squared. And then also negative 11x, you multiply it with positive 1 to give you negative 11x. And then you subtract. Subtracting will take away values of x with higher powers. So negative 11x squared minus negative 11x squared will give you 0. But positive 3x minus negative 11x will give you 14x. And then 14 is less by 0. That's why it just comes automatically here. Now this is a polynomial you are having. You also divide this polynomial. You get 14x. You divide it by the x on the divisor. And then you are going to get positive 14. So let me hope you have understood how this quotient was obtained. So you get that positive 14, you multiply it through by the divisor. So 14 times x on the divisor, you're going to get 14x. And then 14 times positive 1 on the divisor, you're going to get positive 14. And if you subtract, you get a remainder of 0. So that's why we are saying that our polynomial is going to, when it's divided by the divisor which we are given, we are going to get the polynomial function, which is 5x squared minus 11x plus 14. And then on specifying, we say that whereby the remainder of our polynomial function of x is going to be 0, and the quotient of our polynomial function of x is going to be our quotient, and the quotient we said 0 is the value above the root. This is going to be a summary of your assignment to look through and try it out on your own, and you see whether you are going to get the same answers. So you use the examples I've explained to see how these values were attained. So pause the video and you first take the notes, or you can first try it out on your own, and then you resume the video later. Looking at more examples, if you're to look at more examples under polynomials, still involving remainder theorem, we have been exempted with some questions to approach, and we are being told that find the values of a in the expression below if the following conditions are satisfied, and we are saying that in Roman number 1, the polynomial x cubed plus x squared plus 3x minus 5 has a remainder of negative 3 when divided by x minus 2. Now let's first go through a recap of what I told you. Whenever you are given a divisor, you first get that divisor equated to 0, and then you make x the subject. After doing so, you let the function given to be polynomial of x, and then you substitute for that value of x, and whatever you got is a remainder. Now whenever you are given a remainder, you equate that expression you have got after substituting, you equate it to whatever they have given you, because after substituting in polynomials, we say that whatever you're dealing with is now a remainder according to remainder theorem. So that's what we did down below, and we're saying that we gave a general formula for writing a polynomial. Any polynomial function of x is given by a quotient of x multiplied by its divisor, and then you add its remainder. And we are saying that in this case our polynomial function of x was x cubed plus x squared plus 3x minus 5, and is given by the quotient. Now in this case we don't know the quotient, but we are given the divisor as x minus 2, and then plus our remainder. In this case our remainder was given as negative 3. Now always when you have the divisor, you equate it to 0, and then you make x the subject. After making x the subject, you have to substitute for the x in the polynomial function of x. So if you do that, what do you get? If you substitute for values of x in this expression, and I've told you, when you're substituting, we always encourage you to use brackets because it increases your accuracy levels. So you have where there is x, we substitute with 2, which you have got above here, because x is equal to 2 in our polynomial. So you have 2 cubed plus a into 2 squared plus 3 multiplied by 2, and then you less 5 is going to be equal to, now notice that in this polynomial, when you substitute here 2, this is going to be 2 minus 2. So everything is going to be 0. So polynomial of x is going to be multiplying this bracket, which is a 0. And you remain with plus negative 3. Let me hope you have understood that. And then trying to simplify, you get 8 plus 4a plus 6 minus 5 is equal to negative 3. Simplifying further, you're going to get 9 plus 4a is equal to negative 3. And then if you divide through by 4a, you're going to get your a being equal to negative 3. So Roman number 2. Roman number 2 is also the same idea. First of all, you call the formula of the function. Formula of the function, polynomial of x, and a polynomial of x is equal to the quotient, which we don't know, multiplied by the divisor and then plus the remainder. So that's the standard formula of finding any polynomial. Then whenever you're given a divisor, you equate the divisor to 0, and then you make x the subject. After making x the subject, you already substitute it into your polynomial function of x. And you are saying that for polynomial function of x, this is going to be 2 cubed, and 2 cubed is going to be 8. Now here I skip the substitution part, but whenever you are writing, for you are supposed to include it. And then 2 squared is going to be 4. Then minus 4 into a, minus 2 into a times 2. So 2 times negative 2 give you negative 4a. And then plus your a squared is equal to, when you substitute here for 2, everything is going to become 0, like I previously explained. So plus 8. Now in simplifying, you are going to get a quadratic equation, which is a squared minus 4a plus 4 is equal to 0. Now if you look at that properly, that's a perfect square of a minus 2. So a perfect square of a minus 2, you equate it to 0. Finding root on both sides is going to give you a minus 2 is equal to 0 still. And then making a the subject, a is going to be equal to 2 as required. Now in example 2, we have been prompted the same thing and the same idea. We have been told that show that the polynomial of 12x cubed plus 6x squared minus 5x minus 3 is divisible by 2x minus 1, and find other factors. Now to show that something is divisible, that means that we don't need to have any remainder, and that's the main idea behind this concept. So let's look at that quickly. So you put your polynomial under the root, that's the initial step, and then you put your divisor besides the root, and then you get the value with the highest power of x in the polynomial. Now in this case was 12x cubed, as present here, and then you divide it by the highest power of value with the highest power of x in the divisor. In this case it was 2x. So if you divide 12x cubed by 2x, you are going to get 6x squared. Now after getting that, you multiply it with the divisor. So 6x squared times 2x is going to give you 12x cubed. And then 6x squared times negative 1 is going to give you negative x squared, negative 6x squared. After doing that, you subtract so as to eliminate values with the highest power of x. So 12x cubed minus 12x cubed is going to give you 0. Whereas positive 16x squared minus negative 6x squared, you are going to get 22x squared, because negative minus a negative becomes positive. So it will be 16 plus 6, and you get 22x squared. Then the others are being less by 0. That's why we just present them automatically. And then you repeat the step that you have done until you get no division factor. So you are going to get 22x squared. Again, you divide it by 2x, which is present on the divisor. Now when you do so, you're going to get 11x, which is positive. That's why we wrote it here, positive 11x squared. Now the quotient comes one by one. If you have been keen enough in my explanations, it doesn't come as a whole, and I've shown you how to derive it. So after getting 11x, you multiply that quotient you have got with the divisor, and then you record it below your current polynomial. So 11x times 2x, you are going to get 22x squared, and then 11x times negative 1, you are going to get negative 11x. Then if you subtract, you are going to get 6x minus 3, and then this is your current polynomial, and then you repeat the same procedure. So the same procedure, that means that you're going to get 6x, which is present on your polynomial, and then you divide it by 2x, which is present on your divisor. So you'll be getting positive 3. Now you get that positive 3, again you multiply it by the divisor. So 3 times 2x, you're going to get 6x. And 3 times negative 1, you're going to get negative 3. When you subtract both of them, you're going to get remainder as 0. Now, since you have got your remainder as 0, that means that the given factor, the given divisor is a factor to that equation, or is divisible to that polynomial. And we are saying that since the remainder is 0, the polynomial function we are given is therefore divisible by 2x minus 1. And we write a general formula for finding a polynomial. And a polynomial is going to be given by the quotient, which is 6x squared plus 11x plus 3 multiplied by its divisor plus the remainder, but in this case the remainder was 0, that's why we didn't include anything. So the quotient, now they told us to find other factors. Finding other factors, you have to deal with the quotient so that you can find other factors or roots of the function. So to find other factors, you have to prime factorize. So you get the function which you have got in your quotient, and then you deal with it using prime factorization, which you have been studying ever since O level. So we are seeing that the other factors are 2 and 9, and product of factors is 18. So dealing with that, you are going to expand using your O-level knowledge, and then we correct like terms according to brackets. So you're going to find that the other factors are going to be 2x plus 3 and also 3x plus 1. And you're saying that therefore quotient is the same as these factors being multiplied together. And therefore our overall quotient or overall polynomial is equal to the product of all those factors. And we're seeing that the other factors of this polynomial are going to be 2x plus 3 and 3x plus 1 as your conclusion. Now this question involves the same idea, so I'm just going to peruse through it quickly. If you want to take the notes, always pause the slides and you take the notes and then you proceed with the explanations. So let me go through this very quick. And then they have said that example 3, x plus 2 is a factor to this equation. Now whenever they tell you that something is a factor, just know that the remainder must be equal to 0. Because for something to be a factor, it has to divide that polynomial and then you get the remainder being 0. Now they're telling us that find the remainder when the expression is divided by 2x minus 1. So we have said that solution, we start by letting Uace polynomial of x to be equal to that function that you have been given. And we say that whenever you're given a factor divisor, you start by equating it to 0. And you say that since x plus 2 is a factor, you equate it to 0. And then you make x the subject. And then you substitute for it. And then we say that after substituting for polynomial of x, our remainder must be equal to 0. And the reason for that is because they have told us it's a factor. If something is a factor, that means that it shouldn't leave any remainder. So we substitute, we get our polynomial, and we substitute for the value of x. Now, in substituting for the value of x and simplifying, you are going to get p into 2 to be equal to 3 minus 2b. But we got this negative 2 from a factor. That means that whatever whichever substitutions we have made, they must be equal to 0. So that's why we got this expression and we equated it to 0. So making b the subject, you have 3 divided by 2, which is the same as 1.5. So let's go to example 4. Now in example 4, we have told you that the remainder obtained when the polynomial function of x given by this function is divided by x plus 2. Now this question, we didn't proceed with the nth part. They say that find the remainder when x is divided by 2x minus 1. Now this one, probably you can use remainder theorem by equating this to 0. So equating it to 0, you have x is equal to 1.5, and then you substitute it in this polynomial, since you have already got the value of b. Now whatever it will give you will be the remainder. Or someone else can use long division. Long division, the value you get down here will be the answer. So you have two ways of solving it. So example 4, we are saying that the remainder obtained when the polynomial function of 2x cubed plus x squared minus 6x plus 1 is divided by x plus 2 is twice the remainder obtained when the same expression is divided by x minus 3. Now find the value of a. Now this is logic, or it's something that requires common sense. You always start by letting your polynomial to be p of x. And after doing that, you get the divisors, you equate them to 0. So if you get this divisor, we equate it to 0, and we make x the subject, x is going to be equal to negative 2. So if you substitute negative 2 into the polynomial of x, what are you going to get? Now whatever you get is called the remainder. So if we substitute into this, we get the following. Putting p into 2, you are going to get negative 16 plus 4a plus 12 plus 1. And simplifying, you are going to get negative 3 plus 4a. You also do the same to the other divisor, which was x minus 3. If you make x the subject, you are going to get x equals to 3. Now this is called the remainder. I told you after substitution, whatever you get is called the remainder, according to remainder theorem. You also equate the other divisor to 0, so you get a subject as x equals to 3. Now you substitute for x equals to 3 in the same polynomial. On substituting, that's how your value is going to look like. And on simplifying, you're going to get polynomial of 3 is equal to 37 plus 9a. So you're having these two expressions. Now we go to the English part of the question. Now the English part of the question, they say that for the remainder of one is twice the remainder of the other. So this is logic. You have to apply it so that you can find the value of a. And we're saying that 3 plus 4a will be equal to 37 plus 9a multiplied by 2. So if you open up the brackets, you're going to have negative 3 plus 4a. There's a negative here. Negative 3 plus 4a is equal to 74 plus 18a. Now negative 77 is going to be equal to 14a. Now you divide by 14 and you get 5.5. So in proceeding, we're having example 5. Now example 5 is saying that a cubic polynomial given by 6x cubed plus 7x squared plus ax plus b has a remainder of 72 when it has been divided by x minus 2 and it's always exactly divisible by x plus 1. Now when they say that it's exactly divisible by x plus 1, that means that the remainder is 0. Now calculate the values of a and b and also show that 2x minus 1 is a factor. Obtain the other factors of the polynomial. So you are being provided with polynomial of x, and polynomial of x is being equal to 6x cubed plus 7x squared, and then you add on ax plus b. Then if you analyze the question very well, you have been given a divisor of x minus 2. You always equate that divisor to 0, and then you make x the subject. It will be x is equal to 2, and then you substitute it into your polynomial. You have said that the first step is by starting letting. I've been leaving out that maybe it was my typing error. So you let your polynomial of x to be equal to that function, and then you substitute for x minus 2. You substitute for x minus 2 into your polynomial. And then substitute for x minus 2, and then you make x the subject. You're going to get x is equal to 2. And then after getting x is equal to 2, then you should equate what they have told you, because after substitution, always the expression is equal to the remainder, and here the remainder was dictated as 72. So polynomial into 2 is equal to 72. Now, also, if you relate other divisors that you are given x plus 1. If you equate it to 0 and you make x the subject, you are going to get x equals to negative 1. And they have told you for that one is exactly divisible. That means that the remainder is 0 after substituting. Now you are going to use these analogies to get two simultaneous equations that we can solve, and we get the respective values of a and b. So you substitute for polynomial of x being 2, and wherever there is x in our polynomial in this function, we substitute for 2. and substitutions are always represented by brackets. Going further, you're going to get 48 plus 28 plus 2a plus 2b, and then further simplification is going to give you 76 plus 2a plus 2b. Now polynomial of 2, we say that after substituting, always what you're getting is going to be the remainder. So the remainder was already dictated as 72, so whatever our expression was equal to that value. And then correcting like terms, you take 76 this side, so it will be 72 less 76, and then you get negative 4. Negative 4 will be equal to 2a plus b, and this is going to be your equation 1. Then you also substitute for polynomial of negative 1, like we explained earlier above. You substitute it into your polynomial function of x, which you have the expression originally. So substitution, we always encourage use of brackets so that you avoid messing up with the signs. Now using the brackets and putting everything in the calculator, you're going to get negative 6 plus 7 minus a plus b. Simplifying this further, you're going to get negative 1 is equal to negative a plus b. So now you're having two equations. Now we can solve these ones using simultaneous methods, either elimination, substitution, or reduction. However, reduction is not applicable here. So you either use elimination or substitution, whichever aligns your way. So I went with elimination. Using elimination, we subtract equation 1 from equation 2. So you will remain with negative 3 being equal to 3a. So if you divide through by 3, you're going to get your a being negative 1. Now after getting a, you can use any of the equations to get b. So we say that you're going to use equation 2, and then we substitute for a. So substituting for a, it will be negative, the negative here will multiply the negative 1, and you get positive 1 plus b, and you make b the subject. So making b the subject, you take this positive 1 this side. It's going to become negative. So it will be negative 1, you less 1, and then you get negative 2. So your polynomial function of x is going to be equal to that, because you have already found the value of a and the value of b. Now, they have told us to see whether other factors are divisible. Now, to get other factors, we have to get one of the factors which was given, and we put them in a wrong division root. You put the polynomial here, and you put the divisor here. Let me hope you understood how we came up with this, because I've already explained it. So you do everything. 6x cubed divided by x, and then you get 6x squared. You multiply that by the divisor, and you repeat the process until you get a remainder of 0. So your quotient, this quotient here, is always what gives us the other factors or the other roots of x. And we're saying that, but our quotient is equal to this. So we use prime factorization to get other brackets. And using prime factorization, you're going to get brackets of 2x minus 1 and 3x plus 2, and then plus the bracket that we had before. So generally, our polynomial function will be equal to bracket of 2x minus 1 multiplied by the bracket of 3x plus 2 multiplied by our divisor, which was x plus 1. So the other factors of the function were therefore 3x plus 2 and x plus 1. Example 6. If you look at example 6, we are following the same ideas. So basically you have the background of what we are discussing. So I'm going to be very quick, at the same time very elaborative in this example. So we are being given that x minus 1 plus x plus 1 are factors, and when we say that for factors, always remainder is 0, implying that after getting any of these factors and equate them to 0, and you make x the subject, after substituting, you should equate your expression to 0. So you have been given a polynomial of x, which is x cubed plus x squared plus bx plus c. Now always polynomials, we use them in simultaneous equations, and here you have 3 unknowns. That means that you are most likely to solve simultaneous equations of 3 equations. So, and it leaves, and they have said that provided x minus 1 and x plus 1 are factors of that equation, and they have told us that when it is divided by x minus 2, it's going to leave a remainder of 12. Now the question is prompting us to find the values of a, b, and c. So the first thing is to relate. You relate your polynomial function of x to be the formula you have been provided with, and then the polynomial of x, you relate your x to be 1 here. So x is going to be 1. So polynomial into 1, because where did that one come from? If you look at the divisor which you are given the question, x minus 1, you have to equate it to 0, and then you make x the subject. So you remain with x is equal to 1. So when we substitute for x is equal to 1, we expect our remainder to be 0, because these are factors. Whenever you're dealing with a factor, once a factor divides a polynomial, always the remainder is 0. So these expressions are telling us that if we substitute for 1 as a factor from a factor, we should get our remainder as 0. And if we substitute for negative 1, because here we are having this bracket of x plus 1, if you equate that bracket to 0 and you make x the subject, you get x equals to negative 1. And since it's a factor, if we substitute for it, it must give us 0. That's what this expression means. And the last expression means that if we substitute x equals to x into 2, where are we getting the 2? We have in this last bracket x minus 2. And then we are told that our remainders must be 12. So this statement is also meaning that if we substitute for x equals to 2, we must get the remainder as 12. So now let's do the substitution. So if we start with this one, if you make the substitution for polynomial of x being equal to 1, where there is x we put 1. And we have already said that whenever you're substituting, make sure that you use brackets so that you reduce your chances of making errors. So 1 cubed plus a into 1 squared plus b into 1 plus c. Then you are going to get polynomial of 1 is equal to 1 plus a plus b plus c. Then you are going to make a plus b plus c the subject. Making a plus b plus c the subject, you are going to get a plus b plus c is equal to negative 1. And if you are to continue with the substitution of the second function, substituting for polynomial where x is equal to negative 1, substitutions you always put in brackets. And then simplifying, you are going to get negative 1 plus a minus b plus c. Then correcting each and everything. Since these ones are factors, always the remainder is going to be 0. And I told you after substitution, always what you're going to get is called the remainder. So since you have substituted, we equate this expression to 0 because this is a remainder. And correcting like terms, taking values on the other side and leaving letters on one side, you're going to remain with a minus b plus c is equal to 1. So this is your expression 2. Or your equation 2. So let's go to the next expression or the next term. For polynomial substituting for p into 2, we must get our remainder as 12. So let's do that here. So substituting for polynomial of when x is equal to 2, you're going to have 2 cubed plus a into 2 squared plus b into 2, then plus c. Substitution always use brackets. Then you correct like terms. You take figures on one side, you also remain with letters on one side. So you remain with 4a plus 2b plus c is equal to 4 as your third equation. Now the other thing is to solve the equation simultaneously. Now the easier method for A level is the elimination method, and you should get used to it. Now when you use the elimination method and we subtract equation 1 from equation 2, you remain with 2b to be equal to negative 2. So we divide through by 2, and then you remain with b is equal to negative 1. So you have got b. So let's also use the elimination method on equation 1 and equation 3. So if you eliminate c, you are going to remain with negative 3a minus b is equal to negative 5. If you substitute for b, but b is equal to negative 1, you are going to remain with negative 3a plus 1 is equal to negative 5. Simplifying, you are going to remain with negative 3a is equal to negative 6. And if you divide through by negative 3, you are going to remain with a being equal to 2. Then we are dealing with a is equal to 2. Now we are only remaining with c. So we pick any equation. We have decided to use equation 1. We have already got the values of a and we have already got the values of b. So using equation 1, 2 minus 1 plus c is equal to negative 1. So collecting like terms, c is going to be equal to negative 2. And you're already done with the question requirements. Therefore, your a is going to be equal to 2, b is going to be equal to negative 1, and c is going to be equal to negative 2. In this video, we have provided two example 9, and the example 9 is also examining the same concept. So when a polynomial of x is divided by x minus 2, the remainder is 4. And when polynomial of x is divided by x minus 3, the remainder is 7. Now you're being prompted to find the remainder when polynomial of x is divided by x minus 2 multiplied by x minus 3. So this is our divisor. And the first thing is always to let your divisor to be equal to 0. So first of all, we interpret this. When you have this factor x minus 2, you equate the factor to 0 and you make x the subject. That means that x is going to be equal to 2. Now once you substitute for x is equal to 2, they have told you that your remainder is going to be 4. So note that. That's the interpretation for this. Substituting for polynomial of x when x is equal to 2, our remainder is going to be 4. And substituting for polynomial of x when x is 3, our remainder is going to be 7. So take note of that. Now we are saying that the remainder is going to be in the form ax plus b. Or is our remainder is this. For higher powers, when you're provided your polynomial is having a power that is higher than x power 1. So your remainder is always in the form of x plus b. So general formula for writing a polynomial is given by polynomial of x is given by quotient multiplied by the divisor plus the remainder. So our quotient in this case is undefined, but we have our divisor. Our divisor was stated as x minus 2 and x minus 3, and our remainder we related it to be x plus b. So note that always polynomials are always full of simultaneous equations. Now what you do, we always equate the divisor to 0 so that we can get two individual values of x. So when you get your divisor, you equate it to 0, you're going to get either x is equal to 2 or x is equal to 3. So we substitute for each of them, and we say that when we substitute for x equals to 2, we always get our remainder as 4. So pay attention to that. So when we put polynomial into 2, we shall get 2a, because if you put here 2, this one will become 0. So all of this narrows down to 0, and then the remainder will be 2a plus b, which is present here. Now when you substitute for x equals to 3, 3 will come here, and 3 minus 3 is a 0. So all this still is going to be a 0. So you will remain with 3a plus b, which is your polynomial of 3 into 3a plus b. But not the expressions that we started with. We say that if we substitute for polynomial into 2, always our remainder must be equal to 4. And when we substitute for polynomial into 3, always our remainder must be equal to 7. So this is the conditions. So we get two simultaneous equations. The best way to solve these equations is by elimination, and we are going to start by eliminating b. So starting by eliminating b, you just need to subtract equation 2 from equation 1. And then you get your a being equal to 3, and then use any of the equations, like equation 1, to get the value of b. So from equation 1, you shall get to a, which is the same as 2 times a, which is a which is 3. And then plus b is equal to 4. So making b the subject, you remain with 4 minus 6. Simplifying further, you remain with b equals to negative 2. So your remainder, we stated it to be in the form of x plus b. So substituting for a and b, for values of a and b, you remain with remainder of x to be equal to 3x minus 2. Since all the things are in the same approach, I'm going to be very quick with the other examples. So these examples you are being given a polynomial of x is divided by x minus 1, and the remainder is 5. Polynomial of x is divided by x minus 2 and the remainder is 7. So we start by interpreting that p into, this is going to be p into 1, because if you get this factor equated to 0, x is going to be 1. So p into 1 is going to be equal to 5 because that's the remainder. And then for this one here, for x minus 2 as a factor, is going to be p into 2, because if you get this factor, equate it to 0 and you make x the subject, you are going to get x equals to 2. So p into 2 is going to give us the remainder of 7. So p into 2 is going to be equal to 7. So note that. Now they have told us that find the remainder when the same expression is divided by this. Now the first thing, since our divisor is having a higher power, because when you open up brackets you are going to have x squared. So you always let your remainder of x to be in the form of x plus b. And on doing so, you quote the general formula of giving a polynomial. So the general formula of giving a polynomial is given by polynomial of x is equal to the quotient. So here the missed quotient of x multiplied by our divisor in this case is x minus 1, x minus 2, plus our remainder which is going to be in the form of x plus b. So you always equate your divisor to 0 and you get alternative values of x. So you're going to have x equals to this or x equals to 2. Now remember that x equals to 1 is what this factor represents and this factor represents. So we started by interpreting those two components. So we say that p into 1 is going to be equal to, if you substitute 1 in this polynomial here, you realize that if you put here 1, everything here is going to become 0. And if you put here 1, everything here is going to be a plus b. Here, this side, everything is going to be 0. So 0 times 2 of x remains 0. That's why p into 1, you are going to remain with a plus b. Now, when you substitute for 2, for x equals to 2, if you put 2 here, still 2 minus 2 is going to be 0. And this 0 is going to multiply everything this side. That means that you're going to remain with, you put 2 here, you're going to remain with 2a plus b. So polynomial into 2 is equal to 2a plus b. But you are being told whenever you use this factor, you have your x equals to 2 and the remainder is going to be equal to 7. That's why these expressions are present, like I explained in the previous example. So we use elimination, which is quite simple. We subtract equation 2 from 1, and then you remain with a is equal to 2. Arranging, you remain with a is equal to 2. Then use the end of the equation to get the value of p. So from equation 1, 5 is going to be equal to 2 plus b. Then b is going to be equal to 3. Therefore, since you let your remainder to be x plus b in this form, you're going to say that therefore your remainder is going to be equal to 2x plus 3. So looking at the next example, you have been given, now this is a UNEB question, it's around 2004. You have been given a polynomial f of x is given by the quotient multiplied by the divisor plus the remainder. And then you are being told that where q of x is going to be our quotient and g of x, which is equal to this, is going to be our divisor, and r of x is going to be our remainder. Show that remainder of x is going to be given by this expression. So let's look at how it came about. So first of all, you quote what you have been given. Polynomial function of x is always equal to the quotient multiplied by its divisor, and then you add on the remainder. So we substitute for each of them. Now we don't have the quotient, that's why we leave it unknown. But our divisor was stated, which is gx, which was given as x minus alpha and x minus beta. Now whenever you're having two factors multiplying, that means that your remainder is always going to be in this form. Whenever you are having two brackets of the divisor multiplying, your remainder is going to be in the form of x plus b. So note that, because your divisor is having the highest power of x squared, that means that your remainder is always going to be in terms of ax plus b. So note that. That's why we are saying that where remainder of x is going to be given by x plus b. And now, always when you're solving polynomials, you get the divisor and you equate it to 0 so that you can get two alternative values of x. So we are having x is equal to alpha or x is equal to beta. So we substitute each of them individually. So when you substitute for f into alpha in this equation of our polynomial, So pay attention. Where there is x, we put alpha. That's why we are having f into alpha. And if we put here alpha here, you realize that it will be alpha minus alpha. So this expression, all the resultant will be 0. So it will go away. But if we put here alpha, we shall remain with a into alpha plus b. So that means that f into alpha is equal to the remainder, which is a into alpha plus b. So that will be equation 1. And then you do the same with beta. Now if you put here beta, you also realize that this bracket becomes 0. And if this bracket becomes 0, it's going to narrow each and everything here to 0. So you have f into beta. This shows that you have substituted beta. F into beta will be equal to alpha, will be equal to a, which is present on your remainder. A, and you substitute for this x, which is beta. A beta plus b. Now the remaining thing is always to use elimination to make either A or B the subject, because if you look at what we are proving or showing, it does not have any constants of A and B. That means that we are focused at making A and B the subject. So let's start doing that by elimination. So solving equation 1 and 2, if you are to eliminate b and you make it a subject, we shall use elimination. So that's why we are saying that equation 1, Euler's equation 2, you remain with, first of all, the left-hand side is going to give you f into alpha less f into beta. And then this side is going to give you a is a common component, so it's going to be alpha minus beta. Now b minus b will go away. So that's why you're having this expression. Then you make a the subject by dividing through by alpha minus beta. So you end up with this expression. Now I've told you what they're telling us to show, we don't have any constants. So we have got the value of a. Let's also calculate out to see how we can get the value of b, small b. And we always get that after using elimination, we get one equation and we substitute into the value of the other. So we have got the value of a. Now we can pick any of the equations we are having here, above here, and we substitute for the value of a, and we make b the subject. So we are going to say that substituting value of a, which is equal to this, into equation 1. So picking equation 1 and substituting for the value of a, you're going to end up with an expression like this. Remember that all of this is a, and then this is alpha. Then we are aimed at making b the subject. Let's look at that quickly. Making b the subject, you remain with f into alpha minus your value of a. Now here you realize that you have to simplify this, and the only way we can do that is by finding LCM, and our LCM in this case is going to be alpha minus beta. Now this is over 1. That means that our LCM, you're going to multiply alpha minus beta by this. So if f into alpha multiplies alpha, you're going to get alpha into f into alpha, and if f into alpha multiplies negative beta, you're going to get minus beta f into alpha, and then minus the general bracket. Now you have to pay attention when you're opening up the brackets for this, because this negative will multiply this negative alpha f into alpha to get negative f into alpha, but this negative again is going to multiply this negative on negative alpha f into beta, and you get positive alpha f into beta. So you have to pay attention to that. That's where most of you make mistakes from. Now simplifying and correcting like terms, you find that there are some values that are going to go away, but you don't cross them. So you see that you're having alpha minus alpha into f into alpha. So the two of those go away. Then you're going to remain with alpha into f into beta less beta into f into alpha, then divided by our LCM, which is alpha minus beta. But since your remainder, now we have got the values of b and we have got the values of a. So what you need to do is just to substitute your values into the remainder expression. That's why we are saying that since the remainder of x is given by ax plus b, that means that the only thing we need to do is to substitute. That's why we started by substituting for a, and then we substituted later for b. So this x multiplies this one to give you x into f into alpha. And also this x multiplies negative f beta. That's why it gave you xf of beta. Then your b is the same as b is here. That's why we brought it as it is. Now the only thing here is to correct LCM. Now since LCMs are the same, we just have to add the numerators. That's why we just combine the numerators and we added them all at once. Now we correct like terms according to the function. If you look at functions of f into alpha, they're having something in common. So if you prime factorize out components having f into alpha, you remain with x minus beta into f into alpha, then plus, if you prime factorize out components having f into beta, you remain with alpha minus x, f into beta, divided by our LCM, which is alpha minus beta. Now if you look at what they told you to prove, this is the same expression, and hence solved as required. So that was it for that number. If you look at another example, which is the second last example in this case, we are being told that the functions f into x and g into x are polynomials. And you're being told that this one has a repeated factor. I told you how to recognize a repeated factor. You always see a factor that is being squared. And I've told you for such a function, both the polynomial and its derivative satisfy the same factor. So you have to pay attention to that. Now, if you are to proceed with the question, they're telling you that f prime of x, which is the same as derivative of function of x, find the derivative of function of x, hence find the values of a and b in terms of f into a and f prime into a, and then deduce that x minus a is a repeated factor for its polynomial as well as for its function. So let's look at that. So you start by stating the polynomial, and our polynomial has been given by this. And I've already told you, any polynomial is given by the divisor multiplied by the quotient. Now the quotient in this case was represented by gx, and then anything added on is called a remainder. So pay attention to that. Now let's find the derivative of this. The derivative is represented by the prime that is put up on the function of x. So if you are to leave this bracket constant and you differentiate g of x, what will you get? You get g prime of x. So let me hope you have seen that. Now if you are also to leave, let me first remove this so that it doesn't distract people writing notes. Now if you also leave gx constant and you differentiate the bracket, what are you going to get? If you leave gx constant, if you differentiate your bracket, you put the 2 down times the bracket that you're having times the derivative of the inner bracket, which is 1, and you get this. And then you also differentiate our remainder. So differentiating ax, you get a, and differentiating b, you get 0. That's why we end up with this expression. So let me hope you have not got lost. So let's proceed. Now we are saying that after getting the function and its derivative, we are saying that they are all satisfied by the same factor. So you get that factor, you equate it to 0, and then after equating it to 0, you make x the subject. So you find that x will be equal to a. That's why you have to substitute it into its derivative. So the first function was expressing it into its derivative, and then we made a the subject. A will be equal to the prime function of a. Then we get prime function of a, and we substitute it into, we also substitute for x in its function. So substituting for x is equal to a in its function is going to give us capital A, small a plus b, but you have already got our capital A as the same as f prime of a, so you substitute for it in this expression. So in substituting for it, it's going to give you b, and you make b the subject, you're going to get f polynomial of a minus a multiplied by the derivative polynomial of a. So and we are saying that since x minus a is a repeated factor of polynomial of f of x, polynomial of x is going to be given by, now for factor we always have remainder of 0, that's why we are giving it the formula in this form. The divisor multiplied only by the quotient, because always the remainder will be 0. So that's why we are saying that f into a, substituting, must give us 0. That's why you are getting f into a as 0. And the same applies to its derivative. We are also going to get 0 after substitution. And we are saying that if x minus a squared is a repeated factor of polynomial of f of x, if and only if its function is satisfied by the factor, by both the polynomial function of x and its derivative. And since it's a factor, both of them must be equal to 0. So that was the only logic behind that. So you have looked at another example of a repeated factor, which is a UNEB question. So you go through the question and you go through. Now you're given a polynomial growth of x, and you're being told it's a repeated factor. Whereas when you're given a repeated factor, you first state down the function and its derivative. And then if it's a repeated factor, always you equate the divisor to 0. So equating that divisor to 0, you're going to get x equals to alpha if you make x the subject. So your polynomial, you are given, now show that is divisible by this. Now to show that it's divisible by this, you have to get x equals to alpha and you substitute into each of them. If you got 0 on both of them, then your answer is divisible. So this question was answering part B. Sorry for the typing, I mistyped the question. So going to part B, you are being given a polynomial this, and you are being given is divided by this. Whenever you say squared on a factor, that is a repeated factor. So you state the polynomial, you also state its derivative. Let me hope you are well versed with the derivatives. And then you equate that factor to 0. So you remain with x minus 1 is equal to 0. And then making x the subject, you have x equals to 1. But since it's a factor, always factors give us remainder of 0. So you have to pay attention to that. So first step is we are going to substitute p into 1 into its polynomial. And we shall have that. And then the remainder, after substitution, always what we get is a remainder. So since it's a factor, always we equate them to 0 after substituting. And then you correct like terms and then you simplify. So you remain with 4a plus b equal to negative 4. You also do the same to its derivative. So substituting it into its derivative, since it's a factor, always the remainder is going to be 0. So making the substitution, you're going to have 3 plus 8a plus b being equal to 0. So correcting like terms, you're going to have 8a plus b is equal to negative 3. Now using elimination method, we subtract equation 2 from 1. And then you remain with 4a is equal to 1. You make a the subject and you get a quarter. Then you have to get the value of b. You pick any of the equations so that you can make b the subject. So we are seeing that we picked equation 2. So from the equation 2 substituting, you always encourage use of brackets. So a quarter times 8, you get 2. And then plus b is equal to negative 3. So correcting like terms, you take to this side. So it will be negative 3 minus 2. And then you get your b is equal to negative 5. So you come back and you write your polynomial and then as it so that you can present it as it was required, because whenever they ask you for unknowns, you have to present the original polynomial as it was required. So presenting it, you have your polynomial in this form. Now substituting for values to prove whether it's going to satisfy your equation, we bring back these values. Now this is like verification. A student can leave it out or can proceed with it. So since the verification gave us 0, that means that our answers for the values of b and the values of a were valid. And they're telling us that since solve the equation for that polynomial to be equal to 0. Now for that polynomial to be equal to 0, you have to rewrite the polynomial and you say that any polynomial is given by the divisor multiplied by its quotient, but we don't know what its quotient is. So we expand this one. So expanding this one, we get divisor and then we divide it by the original polynomial. And we do the same steps that I already explained earlier on. And then you have a quotient of x plus 3. Now remember that this is a perfect square. You have already got its roots. The only other root that we wanted or any other factor was x plus 3. So that means that this polynomial is going to be given by the divisor, which is this times the quotient. So the root is x equals to negative 3 and the factor is equal to x plus 3. So equate that to 0 so that you can get different roots. So first of all, you have x minus 1 is equal to 0 and you have x equals to 1, or the other bracket must be equal to 0, and you make x the subject, you get x equals to negative 3. So you are being left with an assignment so that you can test your understanding about the topic. So I advise to pause the video and you take down the assignment. That has been it for this video, and this video has been compiled and everything that has been presented has been revised and compiled by Olgembe Yusuf. Now, for those of you in need of special assistance or in need of any inquiries about studying or revision or advanced level learning, especially in sciences, you can reach me out on those contacts. Now, success in your papers. We'll meet in the next video.